All right, so let's get started here. The thing we're going to be covering today is using the unittest.mock object that is within the Python framework. This builds upon the fundamentals that I covered in the unit test workshop from a few weeks ago. The YouTube link should be floating around if you guys want access to that. So anyways, just some brief overview. Mock has been something that's been around since Python 3.3, and I'm using one of the more recent versions. I think we're on, 3.8 now. There's some documentation that's linked, as you can see right here. And what we're about to go through today is inspired by a video that I saw put on by this guy named Mahidi Yusuf. I thought it was pretty good, and I just wanted to build upon that. And of course, the repo, if you want to follow along or play with this on your own, is available on GitHub. You guys should have access to all the links and stuff. Let me know if you have questions about that. So we'll get rolling here. The first thing that we want to ask ourselves is what mocks as a entity do if we're going to take our unit testing to the next level. I know that in the announcement for this workshop, it was kind of described as like, the stunt person for whatever testing you're doing, and I'll expand upon what I mean by that concept. So in general, and I mean, the dictionary definition about what a mock does is it replaces portions of your system under test with mock objects, and you can make assertions about how they were used. So when we have complex systems, maybe external services that we're connecting to that aren't always available to us, stuff like that, it allows us to do what unit tests and testing in general for our software really enables, and that's asserting the behavior of our code by reducing some external dependencies and bypassing functions that are complex or really expensive so that we can have very focused atomic unit tests, which we've discussed previously. One great example where you will see mocks come up is when you're testing application programming interfaces, especially when you're maybe talking to external services that you don't own or you don't have insight into, and they essentially function as like a black box for you. Before we get too far into the woods here, I want to just go over a few quick assumptions I have about you as an audience member. The first one is that you're familiar with the Python programming language and you have installed course resources or at the very least have access to them. And lastly, that you understand the concept of test-driven development and why it's important to have confidence in our code so that we can adapt to change quickly and develop at a consistent pace that's more predictable than just shooting out something that works the first time, but then is very brittle to change as time goes on. So with mock, there's going to be some vocab confusion here that might get you. There is the Python mock object, but we're also talking about a concept called test doubles today. And test doubles, think of those as like stunt doubles for your code. The thing is, there is a test double called a mock, and there's also the Python object that's also called a mock. So don't get too confused on that. The difference is when we're talking about a mock in the Python unit test library, they are class names that refer to something that can do what all of the test doubles we cover today handle. So a mock is kind of like a super object that we can have behave as specific types of test doubles or stunt people in our testing. Magic mock is a newer version of mock that has some of those magic methods, your inits, your news, your dells, stuff like that. The opinion on which you should use when, there are good reasons for either, but I generally try to use mock unless I really know what I'm doing or there's a specific functionality that I can justify using magic mock for, just to keep things a little simpler. As we go through today, I'm going to show you an example just from the straight Python terminal. I'm going to show a simple example using PyCharm, and then if there's time at the end, I'm also going to go through a personal project that I've worked on using test-driven development and show how I have used mocks in something that is like applicable to the real world. So test doubles, that's the main focus of today's discussion. There are 5 types: dummies, stubs, spies, fakes, and mocks. And they all have their very specific purposes. Generally speaking, a dummy as a variable is something you're going to use to make sure that it never happens. So say that there is a test you're doing and you have a specific set of code or set of instructions you want to assert were happening, and there's some conditional branch that you want to make sure doesn't happen, you might insert a dummy at that conditional branch. And so whenever your test for some reason breaks off of the expected path and hits that dummy, instead of going through and executing the other conditional logic, it'll just throw up a return value saying, hey, you called dummy, you probably weren't supposed to be here, and that'll give you some more information you can work with when you try to fix your test or implement that new feature in the right way. Stubs are a read-only type of example. So there is a modifier that will demonstrate in the code later called a return value. And so a stub is kind of like, I hit this method call, and let's say I'm going to a website and grabbing information. A stub would just see, oh, I tried to talk to a website. Because you did that, I'm just going to give you this canned response. And so say that you are trying to make sure you're compliant to a very specific response format, or that you don't want to actually reach out to some external service. A stub is a good example to just make sure that you're trying to trigger those reads from external sources. Similarly, spies are sort of related to that using this called with modifier that we'll get into. They're good for write-only actions. So say I use a function and I try to write to a file, and say that I could be writing a whole bunch of data and that this would take a long time. If I were to do it for real, that would slow down my test a lot. What I can do instead is I can use a spy to say, oh, I tried to write to this file and these were my arguments, and that's good enough for now. I'll have another test specifically testing or asserting the contents of the file, but all I wanted to do was make sure under this set of conditional branches, I call write to file or send to website or talk to API, something like that. Fakes are a mixture of stubs and spies. You can read and write to them. We talk about black box testing sometimes, and a fake could kind of be thought of like that. You know, it's something that does something with inputs, does something with outputs, and maybe it doesn't mirror what happens on the internals of your system, because that would be expensive and slower to test. But you can still kind of get a quick gut check of like, oh, am I talking to this component the right way? Something like that. And finally, a mock is a self-verifying spy, and what that means, I can show you that in the code, which we're going to hop into in just a second here. But again, you'll be using the side effect modifier. So without further ado, we're going to talk about a system under test about my personal fish aquarium that I think works as an example here. But first, we'll do some Python commands just to show you what we're dealing with. So the first thing you got to do is from mock, you need to import mock. And then let's show off what a dummy can do. So we'll make a dummy mock. And that's going to be equal to a mock. And we're going to give it a side effect. I mentioned that earlier, right? So a side effect for this dummy mock could be something like give a file not found error, or really anything. Okay, so we'll create our dummy mock like that. And if we do dummy mock, and we give it, say, an input like file.text, what happens is it kicks back a file not found error. So all that happens is when we try to access this dummy, it kicks back whatever side effect we've told it to do. Say we want to change that side effect, we can do it like so. We can do dummy mock. We can go to the side effect, and we can say throw a type error now. And then if we do, again, dummy mock file.text, we see that we're throwing a type error. So that's an example of what a dummy mock looks like in just the quick Python interactive console. Now we'll take a look at what a stub could look like. So again, we already have mock imported. We're going to make a stub mock. Just instantiate it like so, and we're going to give it a return value. That's that modifier, or that named parameter, rather. And we're going to say that that's equal to 1. Okay, so now if I were to call the stub mock with just any random list of parameters, so let's say 1, 5, and like fish is equal to peppered cory, which is a type of fish I keep in my aquarium. They're kind of like little fish Roombas. Whatever, the stub mock kicks back the value of 1. And let's say we go ahead and we screw around with whatever these values are, it still kicks back 1. Say we change the name of this fish, right, to something else like a shark, still kicks back 1, because every time we touch our stub, we kick back a predefined value. Now, something else we can look at here are kind of the built-in methods that StubMock has available to us. So we'll do that by doing a dir stub mock, and this is something that all mock objects have. So we see these assert statements, right? Assert any call, assert called, call count, reset mock, return value, side effect, which we'll get into when we do an example with mocks, and all of these other things. So these are things that we can use to make some assertions about, in a function call, what happens to our code. The next one we'll take a look at for this interactive session here is a spy. So this is something that is write only. So we'll make a spy mock. And then what we'll do is we'll call some function on it. So spymock.addWater, let's say. And just the value 70. And this returns a mock object, right? Now we can take a look at the assert called with property that we saw from the dir earlier. So we can do spymock.addWater, being the function name that we just called, and we could do an assert called with. And we can say, I want to make sure it was called with 70 as the input parameter. And it doesn't kick back anything because that's true. If we say with 60, it's going to say, well, no, it actually wasn't called. It was called with 70 instead of 60. So, say that we have a system that's taking inputs from different modules or whatever, and we're running it through our test suites, and something changes. Well, if we're clear about what we expect certain functions to receive as input on whatever line we're testing, this is a way that it can do that. So I see a question from astebbing3. So all the test doubles use the mock object, and their type depends on how you implement it and what it does. Yeah, that's right. That's absolutely right. So when you make a new instance of a mock object, that mock object is capable of behaving like a dummy stub, spy, fake, or mock, whatever. And what you need to do is, as the developer, know how you want it to behave in the particular test case that you're writing. And that's specific to Python. Other languages might have different versions. Other test frameworks even might have different versions of this test double approach. But the mock object lets you act as if you have all 5 of these test doubles in one single object. The next thing we'll do is take a look at what a mock looks like, right? So this is something with some attributes in it. And I just want to demonstrate that, and then also a mock with specifications, and then we'll get into a more interesting code example here. So we're going to make an attribute mock, and then we'll assign it some attributes. I got a list here that I'm just going to paste in to save some typing. And what we'll do is we will take the attribute mock. So, right, say we have some mock object with some certain attributes in it. Say this represents some data structure we're working with, what have you. We're going to do a configure mock, and that's going to assign the attributes to this mock. Now, this attribute mock should have all of those properties that we just provided in that dictionary named attributes. So we can do attribute mock, and we can take a look at tank size, 60. We can take a look at fish count, 25, and also lizard count. So this demonstrates how we can create mocks that also have some sort of state associated with them, in addition to just kind of referring to what they do when they're called or written to. And now what I want to do is show off a specification, right? So we have an example of, the stub mock with, or not the stub mock, the spy mock with that add water example. Well, what if we want our spy to be able to do multiple things? Or what if we're trying to capture the behavior of something a little more complex than a single function? Well, you can do that with a specification. So requests is what we'll import next. That's how you do some web stuff in Python. And we're going to have a spec mock, which will be a mock that has the spec of requests, which we've imported. So now spec mock has everything that mock can do and everything that requests can do. So if we do a dir of requests, here's all the good stuff for some built-in networking things: connection errors, null handlers. We got get, put, post, stuff like that. Now if we do a dir of spec mock, we see that in addition to all the good stuff that we had in requests, there's additionally things like assert has calls, call count called, and like assert called once with, things like that. So this is how we can make a mock look like an object that we already have. And so that lets you test out more complex cases in an easier fashion, and it lets you kind of model the real behavior while also gaining these extra functions you can use to check the behavior of the given object during the program execution. That's just a quick overview of what the test doubles are and what they look like in the Python Interactive Console. At the end of the slide deck here, I do have some extra resources that can give you more perspectives on what test doubles look like, but that's kind of the quick primer. So what I'll do next is I'm going to make a new project, right? And so I'm just going to call this the mock workshop. And we'll use the 3.8 virtual environment. That's all fine. And we open this guy up here. So here's the framework in which we can make something. The something we're going to do, I'm going to start off by making a Python package just called code. I'm going to add in a Python file called calls. So I'm going to show how you can use mocks to make interacting with a website a little easier. What we'll do here is make a file called calls, and what this file is going to do is build off that example we had with requests. We'll go ahead and import requests. And the next step we'll do is make a function called getData. Okay, and we're just going to hard code it to try to reach out to a single website and grab some information. So we'll have this response variable. And with requests, we're going to use get to go grab something from xkcd. And what we're going to return is the status code off of that. The next thing we need to do is have a test file to make some assertions about what happens in calls. So we'll go ahead and make a new Python file. And I'm going to make a Python unit test thing called test calls. And I like to work with my tests and production code, as it were, kind of split side by side like this. This is just a personal preference. And it kind of stubs out a little test class for us. I'm just going to call this test calls to be a little more specific. And the test that we're going to do here is we're going to go ahead and test that the get data returns a 200 response code without using mocks. And I'm going to show you differences that this makes in timing, because at the end of the day, we want to have fast tests. So we're going to do a test get data with no mock. And we're just going to assert that the calls.getData, and I got some imports I need to add in just a second, so no worries, is equal to 200. There are some imports we need. We need to import calls. We also need to import IO for a file example I'm going to get to in just a bit. And from mock, when we eventually start using mock, I need to import mock object, and I also need to import something called patch. Those last two don't matter quite yet. So what we have here is we have a call to xkcd, and we're expecting it to return a status code of 200. So when we run this test, we got a passing result Astabbing3 wants some bigger font. Yeah, I should be able to do that for you. So cool. We just did a test asserting that our result is of code 200 okay. And take a look at this. We ran our test in like 0.2 of a second. That's pretty quick. But if we have dozens and dozens of tests, maybe I'd have enough time to blink before I wait for my results. So let's take a look at how we can do this with a mock. The next thing we'll do is we'll define a function called test get data mock. And so we're going to test the same thing, that we get a 200 response code. But we're going to use a context manager here to kind of patch in the response. So with patch, which we imported earlier, the object we're patching is going to be requests, and we're going to patch in the get function, and we're going to refer to that as our get mock. The next thing we'll do is we'll assign it a return value whenever we invoke get mock. So we'll say get mock return value is going to be equal to a mock response of this mock object. The next thing we'll do here is define what that mock response status code should look like. So mock response status code, this property that we're interested in as a result of our function call, we'll assign it as 200. And then we'll do that assert statement from earlier. Calls that get data equal to 200. Import issues with visibility for requests because guess what? We don't import it right here. So yeah, you see what we did here is we're for real reaching out to the website in this no mock example. So we're starting this test, jumping over to our production code, and firing off an actual request. With our context manager approach to patching the get function, we need to specify, well, this is the object, this is the specific function, we're going to refer to it as get mock, and then we can do the same thing where we try to call it. And now take a look at that. We run our test and we get our answer in 0.002 seconds. That's what, 2 orders of magnitude faster than doing it for real? And why this matters is if we're trying to do a test where we just care about, let's assume XKCD gives us this response code, then let's go ahead and do this certain behavior. So we don't want to actually talk to the real service. The next thing that I'll demonstrate is how we can do something with like file operations and also using annotations instead of a context manager approach. So file operations in Python, there's a function called open. What we're going to do here is we're going to use patch, and I'll demonstrate how this works as we build this example up. And in this test, we're going to give advice based upon, some list of names we read in from a string, and we'll just, print out some other string. So the way that I named this example is give advice, and we're doing like a format check. And the technical term for this thing on line 18 is called a decorator. So that's why it's referred to as decorated. We'll have mock open. And something to note about these decorators is that if, say I were to have 2 decorators here, like say at patch decorator 2, the way you refer to them in the parameter list is the one at the top is the one referred to closest to the self, and the one closest to the definition, right? So like your nth patch is going to be like the last example given. That'll make sense when I have an example where we do multiple patching. But just something to know: the order that they're listed in the decorations matches or is related to the order they appear in the parameter list on your test function. Okay, so what we're going to do here is we're going to fake some file input output. So our fake file here is just going to be like a string IO, like say we're reading some kind of text document. So, say Sam and Dan. So really, say this is the result of reading in the file, and then we have a mock open that we have with our context decorator here. And we're going to say mock open dot return value is equal to fake file. So now whenever we call whatever happens in mock open, we should be kicking back the contents of fake file. And the next thing we're going to do is keep our result from doing this fake file operation. So we'll have a result, which is equal to calls.giveAdvice, which is a function we have yet to write, so just a second. And we'll give it some random file path. We're going to make some assertions about what we want our output to look like. This doesn't really matter, just demonstrating like a test-driven development approach of what we want our function to do before we actually write the production code. And just to save a little bit of typing, I'll copy in what our expected output should look like. Now, in our production code side of the house, let's go ahead and write the giveAdvice function. So, right, if I receive this as my input, I want this as my output. Let's go make a function that does that. So we'll define giveAdvice, and we'll say you take a file as input. Now we're going to open the file using a context manager. So with open, the input file, read only, and we'll refer to it as file within this context. We'll start out with our advice string being flatten the curve followed by a carriage return. All right. And then next, we're going to start appending that be sure to wash your hands line for every person in the file. So for person in file, we're going to just concatenate or append, whatever word you'd prefer to use, the person, ignoring the carriage return, and the phrase, be sure to wash your hands. And a carriage return at the end of all that. Okay. And then at the very end here, we're going to return advice. All right. Let's go ahead and run this test. And you see again, that passed in 0.002 seconds. And the interesting part, right? Look at what we did in giveAdvice. We made a call to open, which talks to something on the file system. It needs to talk to an actual file to do stuff and populate whatever data it reads in. But with this this decorator approach to mocking, and we could also do it with a context manager, whatever. With this decorator approach to mocking, we just gave it a quick little potato version of what some input could look like, because it doesn't really matter if there are 5 or 10,000 names in this list, right? Like it'll work. And then we just say, well, whenever open is called, that's what this mock open return value guy does here. We're going to make sure that it's the value of fake file, and then we're going to pass it through and continue processing on giveAdvice, and that's how we get the desired output in our result. And we do it very fast without any actual file input output. So those are two simpler examples. I'm going to jump over to an example of what it's like in this little system under test of my Aquarium that I'm going to demonstrate for you. The next thing I'll do is explain kind of what I'm getting at with this Aquarium demo. So personally, I got some fish that I keep in a big 60-gallon tank. There's about 25 of them, and something I do as part of my maintenance is I change out the water. I make sure that the fish have fresh water to swim in. And obviously, I can't put in more than 60 gallons, but I could put in less than 60 gallons. The thing is, if I were to model this in software to match reality, water changes are kind of slow because you're pumping a whole bunch of water. And say that I were to write like some kind of test to do this with like a Raspberry Pi to control my water pump or whatever, I would want to make sure that it would behave properly based upon how much water it was told to pump into the tank. This is a perfect example of where I could use some test doubles to make some assertions about my system behavior without actually needing to test pump 60 gallons of water. So I'll demonstrate a few ways we can use mocks here, some decorators, and some stuff like that. I'll also demonstrate the side effect thing on a completely mocked out function. And yeah, we got maybe 8 tests to write up real quick, but they're pretty straightforward. Okay, so one example here is I just want to make sure that this water change function here can actually get called if I were to reference it. So what I could do is I can first off start by importing the right things that I need. So I'm going to say from the aquarium file, I want to import the aquarium class. And also we will need to import patch from mock. Okay, so let's go ahead and write our very first test. Our test here, we can just do, I don't know what we can name it. Water change was called. And I'm going to demonstrate how to do it patched here. So we'll add our decorator. So we're going to add a decorator to refer to the water change function within the aquarium file, in the aquarium class, and the water change function. Of course, you need to actually use the word patch if you're going to patch something. And what we'll do here is this is kind of an example of a spy. We just care that something was called, right? So we'll refer to our test double as a spy here. The next thing we'll do is we'll say spy.waterChange, and we'll pass it, 70 as the input. And I just want to assert that spy.waterChange assert was called with 70. All right, let's see what we get. Sweet, cool. I can make sure that I'm checking the input that's going to this function, and nothing else is happening because all the spy is doing is just watching this function. I'll also show how rejecting too much water might look like. One way we could do that is like so. We can do water change rejects too much water. And the way we're doing this is like for real, like that past test example where we reached out to xkcd.com, like actually. And so just to save some typing, I'll paste in what this test looks like. We make an aquarium object, and then we assert that we get an overflow error, a little lambda here, just so we can catch an error condition in our code. We'll go ahead and run this test, and you'll see that this should take about 8 seconds to complete because we are actually going into water change, and boom, right? 8.009 seconds. We can also do the same thing to make sure it accepts enough water. And, this test I'm just going to paste in again for clarity because I think we're starting to get the repetition here. If we go ahead and run this guy, this will take about 7 seconds because it is, again, going all the way into the production code here and running this, hitting the sleep triggers, stuff like that. So now let's start using our context managers, our patches, and we can take a look at what that looks like. So it's going to be 4 quick test cases, and then we'll get into some questions. Following that, I can talk about how I applied this to a real-world personal project of mine. So the first thing we do, again, just to save some typing, is we're going to make a test that's patching the water change function, and it's going to return this side effect thing, right? So this is this is going to be an example of one of those test doubles that references side effect. So we'll call it like a mock, right? Side effects can be like overridden function behavior that happen. So up in our unit test, we're going to define this simple water change function. You'll notice its logic matches what happens in the production code. It just doesn't have the sleep statements. Now, this might not be the perfect way to do it because, this has to be kept in lockstep with the logic of your water change. Maybe what you'd really want to do is just mock out sleep so that sleep actually just doesn't do anything and returns immediately whenever it's invoked. That's a challenge for you as the student to try to execute. So an example of a mocked water change using the patching approach is like this. We can go ahead and run that, and we'll see that it passes very quickly as opposed to the several seconds it actually took. From a syntax perspective, another way we can do this is with that context manager approach. So the way that looks like is we're doing the same thing. It's just instead of this decorator, we do a context manager. Again, we're still referencing the same aquarium function, the same simple water change method, and we are still asserting the same things about what that function returns. Go ahead and run it. Again, passes very quickly. You guys can see how this builds up into something like if we were to write tests for it to accept enough water. I'll just paste in an example here. Again, patch the file, the class name, the function name, and then define what its side effects should be, such as with this simple water change function that we define here. As we get into it, the patched thing comes in, has to be referred to as an input parameter in our test, and we can pass it, say, 42 gallons, and in this case we would expect it to kick back a tall white fountain, because that is what the simple water change does, whereas the real world should be kicking back the string copacetic. Let's go ahead and run it, and then here's what the syntax looks like with a context manager. So again, just demonstrating what it looks like using a context manager versus a patch to use these mocked functions. And again, here's an example of what water change looks like. So that was some pretty straightforward stuff. I'll get into an example of what it looks like on a messenger visualizer project that I've done before. So as we move into what this kind of looks like in the real world, when I've used this on my own projects, there are some pitfalls with mocking and test doubles in general. And first off, like, using mocks is not a complete and total cure-all. Mocks are great at the unit test level, where you want to make sure one thing you're working on works just as intended. But you still need to have that, developer brain. You still need to think about integration tests and journey tests and other concepts about code development. Here are some additional resources I highly recommend checking out with the differences between Mock and Magic Mock, Pivotal, and their approach toward test doubles. But let me show you guys how I've used mocks and test doubles in a personal environment, or a personal project here. So I have this project where I'm visualizing Facebook Messenger data. An example of the output might be like word frequency. So based off of all the messages I've sent to a person, these are the most frequent words after you extract the most common words, stuff like that. And this has been a pretty good project to apply the test double concepts and test-driven development in general. The way, generally speaking, that this works is my project has a source directory and a test directory. And so there are things that will read files, we'll put them into the right data structures, we'll manage information about conversations, we'll display graphs and all sorts of different things. And they all play together to create a whole bunch of graphs and print out like my conversation history with people. Under the test directory, I have tests for all of those files. And then I additionally have some faked out text input that might be passed in if I'm testing how I filter words, and some example skeleton JSON reactions to make sure I'm parsing the Facebook data format properly. One example where I've used test doubles in this project is in the main portion of the program. This does a whole lot of stuff, but one of the things that it does is it writes the messages to a file. And I want to make sure that when I hit write messages that I am calling this write text file 3 times. So what I did was I used a spy. So in write messages, I have a test that goes ahead and makes sure that after this function is called, the write text file function that I've written is called 3 times. So if we go ahead and check out my test code in test main, let's expand out this class a little bit. We can see here that, boom, test print function was called 3 times. So we go into main, we execute the print messages with this mocked conversation data. So we're not actually reading in any Facebook Messenger data. This is just something to kind of make this module think it's talking to the real deal. And then we're going to assert that when we hit write messages, the call count for our mock print function was called 3 times. Or this is actually for printing to the console, which is just the same thing, print versus write to a file. So if we go ahead and run this, boom, one test, 0.004 seconds, telling me that I call print 3 times in this function, and it does the expected behavior. If we want to do tries to create 3 text files, we're doing the same thing. Go ahead and run it. 0.003 seconds, I have confidence that this function performs this one action the specified amount of times. And that's better than me needing to go through and choose like a release or a test configuration where I actually create the data, go run the whole program, and then in addition to making sure that I have the right output, I have to ignore all of these other graphs, which isn't what I care about right now. What I care about is just this one tiny little function. So if I wasn't using mocks, I'd have to run the whole program. I'd have to go into output. I'd have to make sure that there were the right number of files and stuff like that. So mocks are just an easier way to focus in on that one specific behavior you want. And then as your software grows and changes, you'll get very specific feedback on what breaks, and you'll also get fast tests that let you move fast at a consistent pace. All right, so I think that's really all I have for test doubles with Python, building upon the unit test thing that we got up to. If there aren't any other questions or things in the stream chat, feel free to hop on off. I appreciate you guys showing up. Just let me know if there are any questions I can answer. Yeah, so Zeno is asking the path decorator thing. Yeah, and here's an example that shows what I mean. So in the print called correct number of times function here, which corresponds to the print messages thing in that real example I just went over, there are two things that I need to kind of use a test double for in order to make sure that this one specific component behaves the way I want it to. I need to make sure that there's a faked out conversation, so it thinks it's pulling real conversation data. And I need to also change how it references print, because I don't want it to actually print to the console. I just want it to say, oh, I hit print, good enough. So the two patches that I make are source conversation and built-ins print, right? This is something I wrote, and built-ins print is something that comes with Python. And the ordering of the parameters is that thing that I mentioned first. And I guess I did a poor explanation of that, so I apologize. The way that it's ordered, right? The nth item, so here built-ins print is the last item in the list, has to be the first thing that you reference following your test parameters, right? So it'll be self, and then mock print should match up to built-ins print, and then source conversation should match up to mock conversation. Say I were to add another thing like patch source.message, I would then have mock message here. Does that ordering make sense? Otherwise, it's going to have your orders all jumbled around and things won't behave the way you expect them to, or they'll just throw errors. Yeah, that's right. This is definitely a lot more efficient than big blocks of commented out dummy code, especially when you're like, oh, this commented chunk represents control flow A, and this other commented chunk represents control flow B, and whenever you want to test each individual one, you're uncommenting the other one. This makes life a lot easier. Another thing I like to do that's kind of related to that is I use a bunch of different run configurations. You'll see under release, I have 3 different configs. One of them using a word list and the other one using no word list. And so, I'm speaking English with all these people. There are a whole bunch of common words like, oh, whoop-de-doo, my top 5 word is like me or something. So a run configuration that I use for this, and you can do the same thing with tests, right, is I'll specify here are the parameters that I want to pass using a particular custom word list. And then if I wanted to test the behavior of the program without the word list, I would just run the other run configuration where I don't supply the TACW word list parameter. And you can do the same thing with tests. And so I talk about using this in the context of unit tests, but also using the different run configurations is how you can set up more of like the high-level journey stuff that emulates user behavior along a couple, common execution paths. And just to kind of show you one benefit of this approach to writing your software, if I run my entire test suite, I get 46 tests with 1 error failing in 0.021 seconds. So I'm getting super rapid feedback about how my program behaves. And as I tweak one thing, I'm also confident that the other components of my program aren't breaking. And if they are breaking, I get a whole bunch of tests giving me specific feedback. In the case of this particular failing test, it's like conversation object doesn't have attribute get reaction counts. That's because I haven't implemented it yet, because I was in that red green refactor test-driven development lifecycle. All right. Well, hey, if you guys have any follow up, you know how to find me. But I'll close out the stream here and we'll get on with our afternoons.